you ever wondered why the Earth orbits the Sun? The answer you've probably heard is that forces keep the Earth where it is, but that's a bit vague, so bear with me. In this video, you'll learn about forces. Understanding forces is crucial for doing calculations of buildings and structures, as well as understanding the limits of designs, and even in cases like today, understanding why the universe behaves how it does. By the end of this video, you'll fully understand what forces are. So, back to the question at hand. Why does the Earth orbit the Sun? Well, for the same reason that a ball drops down to the Earth when you drop it. That's right. Gravity is responsible for keeping the Earth in orbit around the Sun. Gravity is a type of force that brings anything with mass closer to each other. So let's dissect that for a second. Gravity, the force, brings objects with mass together. That means you and everything in the universe with a mass are drawn together, even a little bit. Why is this important to understand? Well, force has to do with masses and movement. More precisely, force is an influence on the movement of a mass. So when we say that the Earth experiences a force of gravity from the Sun, what we are really saying is that the Sun is influencing the movement of the mass of the Earth. This brings us to the first important formula pertaining to forces. Force equals mass times acceleration, or F equals ma, Newton's second law. We'll get to the first law later, so don't worry. We can elegantly describe forces here using only two values: the mass of an object, which usually doesn't change, and its acceleration, which can change. Acceleration is the derivative of the velocity of an object. This means that when an object is accelerating, its velocity is changing, either in how fast it's going or in what direction it's going, since it's a vector quantity. As a result, the position of the object changes, so in a trickle-down way, force causes the position of an object to eventually change. What else can Newton's second law tell us? Well, let's think about what unit we use to represent how much the Sun affects the motion of the Earth. Here again, we see F equals ma. The units of force are clearly dependent on the units of mass and acceleration. Generally, we use kilograms to represent mass since it's the SI unit. But how do we represent acceleration? Well, velocity can be thought of as how much position changes in a certain amount of time. So, we can say velocity equals change in distance over time, or in units, meters over seconds. Then, since acceleration is the derivative or rate of change of velocity, we can represent it as the change in velocity over time. Unit-wise, this looks like meters per second, or if we rearrange it, meters per second squared. Let's bring it all together. So we're multiplying kilograms by meters per second squared, giving us kilogram meters per second squared. That's a bit of a mouthful, so we just call them newtons, after the formula from which they are derived, and we denote them with a capital N. Wait, let's back up a second here. Earlier I said that every mass creates a force of gravity with. Wouldn't that mean that the Earth also influences the motion of the Sun? Well, that's exactly correct. As a matter of fact, the force caused on the Sun from the Earth is exactly the same as the force the Earth causes on the Sun. That is what we know as Newton's third law. For every force, there is an equal and opposite force. Intuitively, you might not believe that, but remember, F equals ma, meaning that since the Sun is many times more massive than the Earth, if both experience the same force, the Sun would experience a much smaller amount of acceleration. Alright, so what would happen to the Earth if the Sun just disappeared? Wait a second, Earth doesn't stop moving. I thought the Sun was influencing the Earth's movement. Let's think back once again to F equals ma. Now there is zero force acting on the Earth, so the acceleration must be zero, since obviously mass doesn't change. Well, what does this mean? Simply all this means is that velocity doesn't change. So since the Earth has some velocity, it just keeps moving. And, as you can guess, if the velocity was zero, it would never move until there's a force applied. Finally, we have Newton's first law. Objects in motion remain in motion at the same velocity unless acted upon by a force. Objects at rest remain at rest. Took a little while, but we finally got there. What we have just illustrated through our Earth-Sun example is an example of external forces. But the Earth and Sun themselves are made up of many smaller parts that make them whole objects. So how does the Sun stay together as one giant ball of gas? This is thanks to internal forces. They keep things together, and in this case are why all of the particles in the Sun stay together to form one massive mass. So does that mean with enough force we could rip apart the Sun? Well, yes. However, because the forces are internal, we need at least two forces pulling away from the Sun, not just one force. If we take a closer look at the internal forces of two particles in the Sun, we see that one particle pulls on another, but equally, the other particle pulls back on the first one. If we now pull on one of the particles, you can see that the direction of force is the same as the direction that the particle is pulling the other particle. Well, how do we separate them? We can't feasibly pull hard enough on one to pull the particles apart, so the best solution is to pull from both sides. Now, even though each particle is being pulled in the direction it pulls the other particle, as long as the external forces are greater than the internal forces, they can be pulled apart. So finally, we have a full picture of force. Force is the tendency for a mass to move more or less than it already is. Stronger forces make objects change their movement more than weaker forces. Internal and external forces help us to describe how things are made up and how they interact with each other. And we measure forces in newtons. If you found this video useful, be sure to like the video and consider subscribing to the channel. Be sure to comment any questions you have below and let me know what other concepts you'd like to see covered.